Continuing with our naval arc MMD for phase 1 solutions. I have just picked up one question today from past papers, and it also is a part of Captain Subramanian's Stability 1 exercise question. It says it's in the past MMD papers. So what's the question? It is the question is about a barge. The deck and keel of a flat-bottomed barge are identical. So what you see on deck, top view, the shape continues to remain the same till keel, and sides are vertical. The deck consists of two sections. So the bow is the four part is the bow is a triangle. So you can see it's a triangle. This is a four part. The base of the triangle is 12 meters broad, and it measures 12 meters in the 4.5 direction. So this is 4.5 direction. It is also 12 meter. The mid body is rectangle. So mid body till the aft is a rectangle, and rectangle dimensions are 50 meter long and 12 meter wide. This barge is floating on an even keel in salt water with displacement 3,444 tons. So remember, it's on even keel in salt water. Find the position of center of buoyancy with reference to the keel and with reference to its after end. So basically they are asking us to find LCB and KB of the barge. This is what the question is about. So it is interesting question. I just saw in the is somewhere in stability part 1 of Captain Subramanian's book, in exercise 9 or 8 or somewhere. So how do we approach these kind of questions? Here we will divide the question in two parts. First part will deal with the volumes, underwater volumes, and the second part will deal with moments of the volumes to find the LCB. See, you can see the diagram. The half portion is a rectangle and the four part is a triangle. This is the water line. WL is the water line, and below the water line the D is the draft. Okay, so D denotes draft, and I have marked B1 and B2. B1 is the center of buoyancy of the underwater volume, which is below the rectangle area. This rectangular section. So the underwater volume of the rectangular section is center of buoyancy. I have marked as B1, and the underwater volume below the triangular section I have marked B2. Draft D will be same forward and aft everywhere because it's given in the question is floating on even keel. So let's approach this question. First of all, what is given, we make use of those figures. Displacement is given. W is the displacement, and we know that it is underwater volume into RD of the seawater, which is salt water in this case. So displacement given is 3,444 equal to underwater volume into 1.025, which is the RD of salt water, density of salt water in tons. So from here we get underwater volume 3,360 meter. This is the underwater volume. So now the underwater portion of the barge consists of two sections, rectangular section and the forward part is a triangular section. So let's add the two volumes, the volume under the rectangle, the volume under the triangle portion, that total should be equal to 3360, which is the total underwater volume. So what is the volume under the rectangle? Rectangle, even keel and rectangular shape means what will be the formula for the volume? Length into breadth into draft. So for the rectangle it will be length into breadth 50 into 12 into draft. That will be the underwater volume below the rectangular section. Plus, what will be the underwater volume below the triangle? So, you know, it's kind of a prism, triangular prism. Both the faces are triangle. So we are here, remember, we are looking at that portion which is below the water line. We are looking at underwater volume. So the portion which is below the water line. So what will be the underwater volume of this triangular portion? So area of the base, which is a triangle. So what is the formula for area of a triangle? Half base is 12 meter is given, and the height of the triangle, which is this portion, 4.5 portion of the triangle, is given also 12 meter in the question. 12 meter in 4.5 direction. So this is the area of the base into the length. So in this case, what will be the length? Length will be this draft. So this is very important to understand here. This portion, the forward portion, the volume below this triangular underwater volume below the triangular portion will be the volume will be area of the base, which is a triangle. So half base into height, triangle area, half 12 into 12, and the length of the distinct portion, the section will be actually the draft into D. So this is the total volume, underwater volume 3360. So if we solve for this, the out 72 plus 600 so this gives you D draft is equal to 5 meter. Okay, so we got the draft which is 5 meter. Now KB is even keel, and if you see that one portion, the half portion is a rectangle, and KB of a rectangle will be is always half of the draft, and it's an even keel, so it's going to be the same everywhere. So I can easily write that KB will be D by 2, which is 5 by 2, 2.5 meter. Also, we will later on, when we get the LCB, we will see where is the LCB coming, the center of buoyancy of the complete barge, where it is coming. Obviously, it will be somewhere in this rectangular portion only, because this is a bigger area, and being on the rectangular portion, the KB will be half of the draft. So KB is D by 2, is on even keel, remember 5 by 2, 2.5 meter. Now for the LCB. Okay, B1 I have marked here. B1 is the center of buoyancy of the rectangular section. LCB1 is the length of this buoyancy, B1 buoyancy from aft part. I am taking reference from the aft part. So LCB1, of course, is a rectangle, and it's the center of centroid of the rectangle. Center of buoyancy will be halfway only from aft. Total length is 50 meter of the rectangle. So LCB1 will be 25 meter. Now, what about the forward part? Triangular section. Triangular section, center of buoyancy of the triangular section. Triangular, the centroid you see is 1/3 from the base. So it is 12 meter. The total height of the triangle is 12 meter. 1/3 is 4 meters. So 4 meter from the base. So from here it is 4 meters from here. And taking reference from half part, so half portion length is 50 meter. 50 plus 4. So LCB2, longitudinal center of buoyancy of the triangular portion from aft, will be 54 meter. So we take now moments from the aft part. Moment of the volume which is under the rectangle. Volume of the underwater volume of the rectangle. Underwater volume of the rectangle is 50 into 12 into 5. 5 is a D. Before we wrote here formula 50 into 12 into D. Now we know the D. D is 5. So underwater volume will be so and this is plus for the triangular portion, again the volume which is half into base into height into D, 5. We wrote before here 50 into 12 into D. This was the volume, and the triangular portion was half 12 into 12 into D. So we wrote right here again. Now this is volume, but for moments the volume has to be multiplied by the distance from a reference point which we are taking aft. So for rectangle, the volume 50 into 12 into 5 will be multiplied by the length of this the buoyancy from aft, LCB1, which is 25. So we multiply this by 25. And for the triangle, as I explained, will be multiplied by 54. Got it? So volume, underwater volume below the rectangle, multiplied by the length of its buoyancy from aft part of the barge, LCB1. Its total is 50 meter. So it's a rectangle. So center of buoyancy will be halfway from aft, 25 meter. And here for a triangle, I explained the centroid will be 4 meters, 1/3 of the 1/3 from the base. So 1 by 3 into 12. 1 by 3 into 12 is 4 meter. So 4 is from here, from the base of the triangle. But we have 50 meter in the aft. So 50 plus 4. Total will become 54 meters from aft. So this should be equal to the total underwater volume 3360 multiplied by LCB, the center of buoyancy of the whole barge, complete barge center of buoyancy is length. So if you solve this, LCB, open this all equation, LCB will come out to be 28.107 meter. 28.107, so you can see it is somewhere here. This is 25 plus another 2-3 meters. So center of buoyancy is somewhere here on under the rectangular section. The center of buoyancy of the full complete barge, and it's 28.107 meter from aft. Okay, you can put your comments. If you don't understand something, you can put in the comment. I can re-explain, and soon, tomorrow probably, I will be putting another video on this also will be on trim question from past MMD paper. One of the past MMD paper I just pick up that gives a confidence that they are easily, if you understand, they can be easily solved. Okay, thank you very much.